recommendation is, the requirement is for these different systems to be running on VMs, right? If you look at go into AWS or Azure or GCP, and or even SAP, they have very specific VMs that have very specific requirements. So it's primarily a resource driven or resource, hungry environment, right? Memory, CPU. We talked about the HANA DBs getting up to terabytes of many terabytes in size. So, these, and when you use even a SaaS service, even using, say, SAP's RISE service for S/4HANA, they're actually in the CSPs running those VMs, right? So it's not like they're running, it's like a SaaS service where maybe they're doing something like Kubernetes, and you have containers, and you have an ingress, and you have Istio, and all of these sort of, this type of Kubernetes infrastructure that's really focused on 80 and 443 type communication. SAP is, hundreds, there's a lot of different processes, a lot of different applications, a lot of different ports. Now, do they have, containers, or can they run containers for some individual processes? Yeah, maybe their web front end, on a BOP could be containerized, but this is all within the VMs. And this is pretty much abstracted to you. Even if you're a basis engineer running this on-prem, you have processes, you have sockets, these types of things. There may be innovation to do, container type functionality later down the road for the SAP application. But for now, again, these are very, process, CPU, socket, 3-tier application, kind of like your meat and potatoes of how applications have been written, even in a cloud environment. So I hope that kind of helps add some color to some of the things Bushra is commenting on. Okay, so I'm gonna go through the module 6 with the cloud designs with Aviatrix, and the intent of this is to kind of give you an idea of some of the use cases and reasons and value of how Aviatrix can help in these different cloud designs, also giving you them in the context of different case studies. So these are different design patterns with Aviatrix, and customer case studies included. So we'll kind of go through, I'm not going to obviously go through the specific customers themselves, but I'll go through, the type of verticals that different types of customers have used Aviatrix for SAP. And then Numan will touch on and go through in depth the MSP portion. So I'll start with self-managed and kind of go through sort of these 6, I guess could be considered 6 sort of pillars or 6 sort of essence of Aviatrix, and the case studies sort of showing those different use cases. So the first is high performance encryption. The second sort of case study is all about the simplification of native CSP networking for SAP. Another will be on improved security to protect this business critical application like S/4HANA and other SAP apps. The fourth is how a case study on how we can kind of go and show deep visibility and fast troubleshooting. So each one of these is going to have like a description and then a diagram, a network architecture of showing what we're talking about. And then we can kind of go through those and you can see them in a network architecture. And then the last 2 are about consistency and having a consistent architecture for S/4HANA access, and then high availability and reliability, right? So I'm going to spend a little bit of time on why and sort of where we sit. So basically, business critical applications really demand this business critical infrastructure. And if you look at other advanced cloud infrastructure companies, they all sort of sit and have their own separate lane, right? When you think of automation, HashiCorp is really the leader in automation, primarily with Terraform, and actually Aviatrix is a Terraform partner with HashiCorp and a provider, and we'll go into that in a little bit. And then networking and security software, really for advanced cloud networking and security across clouds, is where we sit. We did kind of talk about this a little bit earlier, but just to reemphasize, it's all about consistency, right? Consistency with multi-cloud networking, consistency with visibility and control, consistency with security, and consistency with automation in terms of how users, warehouses, edges connect into the cloud, and how data centers or colos connect into the cloud. So if you look at what are those components, they're broken down into really two components. One is the data plane component of the platform, which is airspace, and that has within it embedded telemetry and distributed control. And that has a control plane connectivity back into Copilot, which provides the operational visibility and programmable intent. So like any large distributed routing system, you could kind of think of Aviatrix. If you're a networking kind of person, you could think of airspace as the data plane or line cards, and Copilot and the controller as the sort of routing process. So what are some of the main pains of SAP, really from the top down, right? So business managers, especially if you're doing a very complex migration or a business transformation, right? These can take 2, 3, 4 years. And I was reading a statistic, with SAP, because it's so complicated, there's a 40% chance every SAP business transformation project is going to be overrun. But during all of these complex projects, they're fundamentally, all of them say, we have to do all this and the system can't go down, right? So the business managers are worried about downtime. The basis operators are worried about, all right, Murphy's Law, things are going to go down. What is my recovery time? And then for the cloud networking folks that build the networking and security for these applications, they say, all right, well, if I do have a problem, how do I actually, solve for the complexities of cloud and the fact that I can't see it, right? I mean, SAP is great when it's running and working, but when it's not, it's probably one of the most miserable applications to troubleshoot, right? So the blame flows down, and it's obviously, the first thing people blame is the network, right? And I hear this from customers when they use Aviatrix. The application team can't blame the network all the time. They still do, but now the network folks have the evidentiary data, they have the visibility and control, they have the simplicity, so that as soon as the network is blamed, or even before, they have ways of having visibility and control into that network to show the application teams, to show, all of the things happening, so that the application team can't just use the network team as the scapegoat. So what ends up happening is, as you, at the networking layer, create simplicity and visibility, the basis operators now have speed and agility, and now the basis managers have more confidence in their uptime. And this simplicity and visibility can be across all the different SAP services, right? And it can, if it all ties into this Aviatrix intelligent cloud networking, it can be for both your digital core for S/4HANA, it could be for all of your SaaS services and all the other components that fit into those SaaS services. So if you kind of break down those components, and this is where we're going to go into use cases and customer stories for each of these key benefits. It first starts with project benefits. I talked about what is the main driver for SAP and the project benefits of using Aviatrix is that it helps maximize uptime, application uptime, and minimize project costs, right? So how do we maximize uptime? Well, we simplify the deployment and the day two operations. We remove the CSP networking complexities. We kind of talked to and showed, the different nuances and complexities of deploying SAP's S/4HANA in AWS, Azure, GCP. And we can bring effectively troubleshooting from weeks to minutes, right? By being able to give you that same visibility and control you're used to on-prem. You don't have to have, many days or possibly weeks of troubleshooting when you're trying to sort of resolve these issues of whether it's an app, whether it's a network, whether it's this or that. And then in project costs, right? Reducing consulting costs by simplifying and using Aviatrix to manage and deploy your network in the cloud. You can, you don't need to have expensive consultants. You can accelerate these project timelines, and then you can reduce the delays, because the networking, just like electricity, it has to be done, but it has to be done right. And if it's broken or if it breaks, then it becomes a big problem for the entire business. So if you break down these key benefits, and I'm going to go into each one of these, so I'll just kind of touch on each one briefly, but then we'll go into the use cases or customer stories behind them, is high performance encryption. One of our intellectual properties as a platform is our ability to have high performance encryption for data transfers. So we have an ability to create, upwards of 25 gig per VM from on-prem to the cloud, and between clouds and within a cloud up to 100 gig of high performance encryption. And one of the things SAP recommends is to encrypt everywhere where possible. The second is the simplification, right? We're going to go into our ability to simplify the CSP networking with say the overlay or floating IPs, with C/4HANA with the overlapping address spaces, and these types of things, using NAT as well as route propagation. The third is securing S/4HANA, right? You're moving your database, your business critical database, from on-prem to the cloud, but you need to secure it, right? This is essentially your lifeblood. You need to restrict and who accesses it, how. You need to be able to do threat detection, mitigation. You need to be able to make sure you're still, providing regulatory compliance. You have auditing from the network and security perspective. The fourth is visibility and fast troubleshooting, right? We hear this time and time again, resolving basis versus network versus SUSE issues, right? It's the network. No, it's the basis, there's a process on the SAP system that's not running or running slow, or no, it's the latest kernel or patch that the SUSE or Red Hat person just updated, right? So having that deep visibility and fast troubleshooting helps resolve, these three parties, sort of going back and forth as to the problem itself. Consistent architecture, right? We're going to talk about how you can create a simplified, repeatable architecture. If you look at what we showed for AWS, Azure, and GCP, each of those sort of has their own different way of creating a network architecture, but there's no company out there that gives you a consistent, repeatable, multi-cloud network architecture, right? And then high availability, right? The need or requirement to have active-active, HA, leveraging these hyperscalers availability zones, and then be able to scale up and down. So let's go through the first sort of use case is, the requirement for high performance encryption, right? So if you look at this architecture here, you can see this is an AWS architecture with, say, an SAP BTP service coming in as a private endpoint. But your ability to connect from on-prem to the cloud through the transit FireNet here, and then have your prod and your dev and your third-party landing zones all connecting over this high-performance encryption links, right? So the connections from on-prem to the cloud can be upwards of 25 gig per VM or colo instance, right? And you can scale that out horizontally, right? We have customers that have upwards of 100 gig from on-prem to the cloud of high performance encryption. And then the connectivity from prod to dev and from ingress to dev or ingress to prod or shared services. So this high performance encryption between these VPCs down to the transit, and then having this hub and spoke architecture is really one of the values that Aviatrix offers. And the use case, and one of the customers that I'm referring to is a pharmaceutical company that essentially was doing a brownfield migration, and they required a master data migration. They had terabytes of data that they needed to send from on-prem to the cloud. These data tables of this master data migration really, if they used 1.25 gig, it would have been 5, 10, 20 times longer, right? And their requirement was for the links from on-prem to the cloud to be encrypted, right? So by using Aviatrix's high performance encryption from on-prem to the cloud, the master data migration, which was key to, again, this timeline of doing a brownfield migration for SAP from on-prem to the cloud. They needed to first, what did they do? They first moved dev, and they made sure dev worked, right? So they have ABAP, they have HANA, they have the HANA system replication between them with the SUSE environment. They needed to move the data to the dev environment and validate that works, right? They need to validate it first in the dev environment, and then they move it to production, right? So master data migration was huge for this pharmaceutical company that needed to do a business transformation migration from SAP S/4HANA from on-prem to the cloud. That's sort of the first use case that we kind of walk through. The second is the simplification of native services, right? So this company is actually a cosmetic company that I'm talking about, that was one of the first companies to migrate in AWS to SAP. And what they really had a challenge with was they had a lot of VPCs as well as on-prem connectivity with the AWS TGW, and it really became hard for them as they kind of scaled out and connected to on-prem, just solving for the routing of the overlay IP as well as the VPC route propagation, right? So in this example, you see on the top left, this production environment is running 10.1.0.0.24. But they have the overlay IP as 192.168.1.1. So to actually do that route advertisement, right, from this production HANA system to either the BTP service running the business transformation platform, or to on-prem where they're running, they're running Studio or they're running SAP UI. They needed to be able to propagate that 192.168, which was the overlay IP that represented this HANA system, right? So just that simplicity of being able to propagate these routes automatically, be able to control who receives them, how they get sent in a centralized way in AWS, as well as across clouds or to on-prem, really was of a big value that we offered. The second one was the overlapping IP addresses. Now, this company is actually a veterinarian company that is using C/4HANA, basically the customer cloud for SAP, to offer their storefront. So the storefronts come in and they go to what's called an omni-channel. Think of it as an AWS sort of place to go shopping, right? You use Amazon to do your shopping. Think of this as a hosted service by SAP called their consumer cloud, and storefronts that needed veterinarian equipment would go to this website. That's domain is owned by the veterinarian company themselves, but C4HANA was the commerce cloud that was front ending that. And so what ended up happening though is that this veterinarian company still owned and wanted to own the back end systems. So they had Kubernetes environments that were running the production application that basically talked to SAP's consumer cloud to fetch the orders. They had their own SQL databases, their own MFAs, their own DNS to do ETL type systems or SQL system, SQL queries to measure, what's being transacted where. So they owned the back end, as well as they had MuleSoft and Salesforce and Boomi and Solace coming in and needing to access the data itself through what they're doing and adding value to the data, as well as MuleSoft to update different systems and being sort of that broker, as well as to on-prem, right? They still had some legacy systems on-prem. It could be, SAP UI, it could be, the studio, HANA Studio. So they needed a way, but the problem is this C4HANA system required certain IPs that this veterinarian clinic could not use. They couldn't use 10 addresses, certain 10 dot addresses or 172 addresses. And they actually had overlapping CIDRs, both to on-prem. So those same CIDRs existed on-prem that SAP's RISE was using, as well as overlapping IPs in their Kubernetes environment. But they weren't going to go re-IP their on-prem, or they weren't going to go re-IP their Kubernetes deployments, because there's so many Kubernetes deployments. They had a whole bunch of legacy on-prem systems. Re-IPing was not an option. So one of the services that we offer is the ability to do a mapped NAT. So we created a RISE landing zone, which effectively did a mapped NAT of the SAP services and then advertised those natted services, the natted storefronts, essentially over private IP, to Kubernetes, to the SQL backends, to on-prem, so that they didn't have to re-IP. And that just solving that complexity really, made sure even the timelines associated with this project were met, right? There was executive CIO level meetings on a weekly, daily basis to meet these timelines because of the new B2B, B2B2C type offerings that needed to be implemented, and these storefronts needed to access for the inventory and and veterinarian equipment that the company was selling, right? So there was a business initiative in this architecture and this solution of just solving for overlapping IPs. Obviously, building all this connectivity and building this architecture was very important, but just solving for this overlapping IP space was really one of the big use cases in this customer's environment. The third is securing and being able to segment and easily insert next-gen firewalls, right? So the third sort of use case is segmentation, network segmentation, as well as inserting next-gen firewalls. So you create this environment where, you want to make sure when on-prem talks to the cloud, and when prod and dev and shared services, you're able to make sure DBAs, for example, when they're connecting to a production SAP environment or a development SAP environment, you can create these segments and create these this ability to route traffic through next-gen firewalls to make sure you're doing your layer 5 through 7 inspection, or you're segmenting production from dev and shared services for compliance reasons. You need to show that you have regulatory compliance and corporate compliances to keep this isolation in place, and you have routing level segmentation, which was what Aviatrix offers, and then layer 5 through 7 type inspections with next-gen firewalls. So you have ways of showing this and proving it and having that evidentiary data to make sure you're in compliant with your corporate and regulatory entities. The sort of fourth one is this deep visibility and fast mean time to resolution. And I'm going to go through this when we go through the day 2 operations module. So these are just a couple of screenshots, but really resolving basis versus network versus SUSE performance issues faster. Right, being able to look at and discover SAP service instances, the services themselves, being able to then create sources and destinations to then have deep insight into how a source connects to a destination. You can also look at the network traffic itself. The Aviatrix gateways also provide the ability to look at all traffic in a time series manner, and then give you, these are, top talkers. These are all my sources to all my destinations. This is where all my traffic's going in one cloud, in the edge, as well as any cloud, right? So you have this holistic view all in one place with your unique IPs, sources, and destinations, as well as a map, right? A map of your environment and how it's connected, and be able to identify your database, your customers and how they're coming in, if you're using a SaaS service like Ariba or SuccessFactor, how are they coming in and connecting, and what does that look like, right? You could draw a static map, but that's not real time and showing you what's up, what's down, latencies, and that sort of thing. So really being able to provide real-time application flow analytics, latency, application intelligence, and what we call intelligent cloud networking. Okay, so consistent architecture, right? And this is, you kind of notice probably in the drawings, you have this consistent repeatable design, and you have third parties, you have RISE services, you have ways of connecting in. So being able to have this repeatable design with your hub, and then that connecting to various spokes or edges, and hub and spoke model, where your edges and spokes could also be third-party landing zones. They could be SaaS services, VNet injected services like SAP's BTP service and a shared services VNet, where you have prod and dev. But you'll notice here, and I showed you this also, I'll also show you this in the next slide with the RISE services, but it's a consistent architecture of how your backbone is created, how your edges and spokes are attached, how your on-prem is attached, third-party landing zones, ingress, egress, all of that is done in a repeatable way, and in the same way, whether you're talking AWS, Azure, or GCP, Alibaba, as well as Oracle. So regardless of your cloud, this architecture is the same. And then also, this Terraform provider giving you that consistency, right? You can architect you can draw up and design a consistent architecture, but the execution and implementation of that is only as good as the automation that you're using to deploy it, right? If you have somebody handcrafting these things, building this in Azure and this in AWS and this in GCP, you have no way of providing governance and ensuring that there's a consistent infrastructure as code deploying your environment, right? You have to have a way of doing that, and the right way to do that is using something like Terraform, where the modules and the code itself to deploy this is very easy. The modules for a transit FireNet is exactly the same. You just all you do is decide which account to use and the region and the account, meaning the CSP account, but the architecture and method of deployment is exactly the same. Same thing with ingress, same thing with third parties, same thing with shared services. You can do this in a consistent way, and we certainly recommend that being done in using Terraform to provide that consistency. So the third, I did want to mention the RISE with SAP services. So in this deployment here to the right, you'll notice that they have, for example, S/4HANA in the RISE SaaS service, but they still, and they have an express route circuit to that RISE environment. And that's I've seen this definitely in some environments where this is how SAP is done. It's done in a SaaS type service. But in the end, data still needs to connect to other data. And although SAP likes to think or say that they're the center and they're everything to everyone, there's still third parties. There's still, your own systems that need to connect into S/4HANA and SAP and run your specific applications, your own queries. You have third parties like Solace or Boomi or Salesforce that need to access this data. Even when you're using a RISE service like S/4HANA, where your S/4HANA system is in SAP's accounts, you still need to extract the data, you still need to get to the data, and that's still your responsibility. So if you're in the process of vacating the data centers and you're doing this migration, you still also, if you're moving to this digital transformation where you have a cloud first choice, or a cloud first mandate, not choice, mandate to actually run these applications, you need to and are responsible for connecting into SAP to get to that, right? SAP is not going to help you necessarily connect to Salesforce or connect to your own SQL database or connect into MuleSoft or Boomi or others. It's your responsibility. So although you don't have S/4HANA in your self-managed accounts, you're still responsible for that connectivity to SAP, to look at your data, to connect to it to third parties, to connect to it to different, if you have manufacturing plants, fleet management, these types of systems, you have to connect all into SAP's S/4HANA, right? They aren't going to go do that for you. So this is where this design really comes into play. Again, it's a repeatable design and shows that you can have that same architecture, whether you're in Azure, AWS, GCP, and then have with our gateways, even gateways running in SAP to provide that high performance encryption from this, say, RISE landing zone into the RISE environment itself. And lastly is really about high availability and reliability. The promise of cloud is to be able to scale up, scale out, scale down. So for each of the gateways, we have ways of either doing, all of them are active. There's no idea of active standby with wasted space, or wasted VMs just sitting there not doing anything. Everything is active, full multipath HA, leveraging these availability zones and the scale of the hyperscalers. But then being able to scale up and down the gateways themselves based on performance, right? You want to scale up or scale out, when you do need or have that need for growth based on performance. And then you want to be able to scale down, right? When you're not using these resources. So if there's a situation where the CPU is 90% over 5 minutes, you can scale from a T3 small to a T3 medium. This is what we call vertical scaling. The other option too is to do horizontal scaling. So in AWS, you can use, and we would deploy this as part of the infrastructure, a gateway load balancer, right? So load balance, where the route table's next hop would point to the gateway load balancer endpoint, and then load balance across gateways across 3 AZs, and you could scale horizontally. As the number of AZs, say in US East, you could scale up to 7 AZs, or depending on your performance, you can scale out or scale up. And those types of decisions of scaling can be based on, going back to Copilot, which we'll demo in the operations component or module. Those decisions and criteria can be baked in, or be time-based or be resource-based, and make those decisions. So.